Greetings to all the candidates preparing for advanced level out there, and welcome to the GCE Maths panel. In this particular lesson, our focus is on the theory of quadratics, and we will be looking at factorization of quadratic equations, the difference of two squares, and a proof of the quadratic formula. We will start by looking at this first example. To factorize the equation x squared plus 3x plus 2 equals 0. Before you start, you must make sure that the equation is in the general form. Ax squared plus bx plus c equals 0. Let's get to a rough sheet and see how we can do this factorization. So the first thing to do is to find two correct factors that we can use in breaking down this middle term into 2, such that we are going to have 4 terms on the left hand side, because it is easier to factorize when we have 4 terms than when we have 3 in the world of quadratics. So we start by stating the values of a, b, and c for this quadratic equation. The value of a is the coefficient of x squared, or it answers the question, how many x squared? So a here is equal to 1 because we have just one a squared. And the value of b is the coefficient of x, or it answers the question, how many x? So we have plus 3. The sign is very important. Since it's just positive, I can just write the 3. And we copy out the constant term here, which is plus 2, or just 2. The next thing is to look for AC. AC is the product of A and C. AC here equals 2. Next, we look for the pair of factors of this AC, that is of these 2, that when we multiply, we will have 2. So we look for 2 numbers that when we multiply, the result is 2. So we have 1 and 2, we equally have negative 1 and negative 2. Note that in the world of quadratics, we have negative factors. It has satisfied the first condition. The second condition is adding this pair of factors and see the one that will give us this middle term, which is plus 3. So when we add the first, we have 1 plus 2 equals 3, and the second 1 plus 2 equals negative 3. So our correct pair here is 1 plus 2, because our b is equal to plus 3. Now we move back to our equation, and we are going to replace that plus 3, we replace this plus 3 by these correct pairs of factors. Note that this 1 and 2 stand for plus 1x, and this one for plus 2x. So I'm going to replace this plus 3x by plus 1x plus 2x. We know that 1x plus 2x equals 3x. The key is to get the correct factors. Another students may use this one, but we know minus 1 plus minus 2 is not equal to plus 3. So be very careful. Once you have the correct factors, we are very sure that factorization is guaranteed. Alright, so we now cover our worksheet and continue. We know that our correct pairs of factors are plus 1x and plus 2x. So we are going to write this as x squared plus 1x plus 2x, and I continue with these 2. I copy out everything. The only thing that is changed here is this plus 3x. That's equal to 0. We now group them in 2's. The first 2 terms we put in brackets. We skip the plus sign and group the next 2. Then we will now have the highest common factor in this first bracket is x. We factor it out and we'll be left with x plus 1. Plus, in the second bracket is 2. We factor out the 2 and we'll be left with x plus 1. And that's equal to 0. Note that the values in these brackets must be the same. If these values in brackets are not the same, then there is a problem with their factorization, or the given quadratic cannot be factorized. It cannot be factorized, or there is a problem with the factors you have chosen. We now copy out one of these brackets, and the remaining terms outside the bracket we put in another bracket and equate to 0. At this level, it is said that we have completely factorized, and from here, if the product of 2 numbers equals 0, then either the first equals 0 or the second equals 0. That's the idea that will be applied here. So we say x plus 1 equals 0 or x plus 2 equals 0. And those gives us the roots of this equation to be x equals minus 1 or x equals minus 2. Note that this x plus 1 into x plus 2 are the factors of this quadratic equation. When we completely solve for x equals something or x equals something, these ones are called the roots of the quadratic equation. This quadratic equation written like this without this equal to something is called a quadratic expression. So an expression is a quantity which does not involve the equality sign. Let's take a second example. Here we are given x squared minus 4x plus 3 equals 0. The first thing to do is to state down the values of a, b, and c. Here our a is 1, our b is minus 4, and our c is 3. Those are the coefficients and the constants. We look for ac, that's the product of a and c, that is 1 times 3, which gives us 3. We now look for the pairs of factors of these 3, which when multiplied will give us 3. We have plus 1 and plus 3. We equally have minus 1 and minus 3. We add each of these pairs to see which gives our b term here is minus 4. This our middle term here is minus 4. As you can see, we are going to add them and see which of them will give us minus 4. So the first one does not, but the second one gives us minus 4. What does this tell us? This tells us that we are going to break down this middle term into minus 1x minus 3x. So we copy out our quadratic equation and we replace this minus 4x by minus 1x minus 3x. And we group them. The first group, this x is the highest common factor, so we factor it out. We'll be left with x minus 1 in brackets. We bring down a negative sign. For this other group, we have minus 3x and plus 3. The highest common factor is 3. We write down the 3. Now, minus 3x divided by minus 3 gives us x. We open brackets and put it inside. And plus 3 divided by minus 3 gives us minus 1. That is equal to 0. We now see that in this bracket we have the same quantities. We copy it out into one bracket, and what is left outside in another bracket, that is equal to 0 at this level. Either x equals 1, either x minus 1 equals 0, or x minus 3 equals 0. And this gives us the values to be x equals 1 or x equals 3. You can watch this video as many times as possible if you do not grasp a particular concept. But with the numerous examples that has been given, we assume or we think that you actually grasp the concept. Let's take 2 more examples, but we'll not emphasize much on the last one. We are looking at just the trick in the question. Our next question here, we are going to have multiple factors. We have been looking at just 2 factors. Now look at the case of multiple factors. Here, our a is equal to 2, our b is plus 1, our c is equal to minus 3. Our AC is 2 times minus 3, which is minus 6. And we are looking for pairs of factors that when we multiply, always start with multiplication. When we multiply, we will have minus 6. We have 1 and minus 6, minus 1 and 6, 2 and minus 3, and minus 2 and plus 3. We start adding them to see which one will give us a b, the coefficient b. Note that b here is plus 1. So this first one, when we add, it does not give us 1. The second one does not give us 1. When we add this, it gives us the minus 1. The last one gives us that plus 1. So it means that our correct pairs of factors are minus 2 and plus 3. And even when you add minus 2 to plus 3, you have plus 1, just like what you have here. So our correct pairs of factors will be 2x squared minus 2x plus 3x minus 3 equals 0. We group them. We factor out the first one. The highest common factor is 2x. We open the brackets. 2x squared divided by 2x is x. Minus 2x divided by 2x is minus 1. Bringing down our plus sign. The highest common factor in the second group is plus 3. So we have plus 3x divided by plus 3 is x. And minus 3 divided by plus 3 is minus 1. The brackets are the same. That's equal to 0. We copy out one of the brackets and the rest in another bracket. At this point, either the first bracket equals 0 or the second equals 0. And this gives us the value of x to be x equals 1. Or x equals minus 3 on 2. Please try to solve all of these questions again. There's a trick with this last question, and that is our focus here. The equation is not in the general form. So our a is not equal to 5. This is where you should not make a mistake. Because no matter the position of x, it is the coefficient of that x that gives us the value of b. But what gives us the value of a is the coefficient of x squared. Equally, at this level, I cannot determine the values of a, b, and c because everything is not on the left-hand side. So I first of all have to write it in the general form. So in the general form, you have minus x squared plus 5x minus 4 equals 0. Now we can clearly see the values of a, b, and c to be equal to minus 1, plus 5, and minus 4. This one can equally be written like this. Another student may decide to multiply all through by minus 1 and bring everything to the left-hand side. And this equation will be of this form. So the equation has not changed. It's just the same thing. The only difference is that their curves will be inverses of the other. While one will look like a mountain, one will look like a hill. So this one that the equation of x squared is positive will look like a valley. This one that it is negative is a hill. We will look at properties of quadratic curves in the next lesson. Alright, so our AC is equal to 4 and pairs of factors of 4, that when you multiply you have 4, you have 1 and 4, minus 1 and minus 4, 2 and 2, minus 2 and minus 2. And when we add them, our b here is plus 5. When we add them, the first one gives us 5. So we are going to break down this into minus x squared plus 1x plus 5 plus 4x minus 4 equals 0. We group them and factorize, as you can see, and this is what we have. So at this point, copy out one of the brackets, and the other one we have minus x plus 4 equals 0. And we simplify, our values will be x equals 1 or x equals 4. When you solve this one, you will have the same thing. So as I've said, the only difference is in their curves. While one slopes upwards, the other one slopes downwards. For the difference of two squares, these are special types of quadratics in which we have a square minus a square. Note that when you multiply a number by itself, you get a square number. For example, 1 times 1 is 1, 2 times 2 is 2, 3 times 3 is 9, x times x is x squared, and a times a is a squared. And when you subtract a square from another square, it gives you a difference. This is this difference which we term the difference of two squares. Let's take an example. 9 minus 16 is a square number minus a square number. So that's the difference of two squares. X squared minus a squared is the difference of two squares. 1 minus 4y squared is the difference of two squares. And these differences can easily be written in the factorized form, because this second one is a quadratic and the third one is a quadratic. We can write them in factorized form as follows. 9 minus 16 will be equal to, you take the square root of each of these squares. The square root of 9 is 3, the square root of 16 is 4. So this is what we do. The square root of 9 is 3, square root of 16 is 4. So the difference of these two squares when factorized is written in this shortcut I've given here. Root 9 minus root 16 times root 9 plus root 16. So just write 3 and 4 in those brackets. One bracket is negative, the other one is positive. That's the shortcut. No waste of time. The same with this one. Square root of x squared is x, and square root of a squared is a. So you have x and a, x and a. One bracket is positive, one is negative. Anyone can be positive, anyone can be negative. Do not do this for the sum of two squares. The sum of two squares is different. We are going to look at that in another lesson. The sum of two squares does not work like this. Thank you so much. And for this last one, this is what we have. So 4 minus 9x squared is the same thing. We have 2 minus 3x, because the square root of 9 is 3, the square root of x squared is x. And the last one too is the same. For x squared minus a squared, or x to the power 4, the square root of x to the power 4 is x to the power 2. And with this last one, you first of all have to see that the square numbers are hidden, because they have multiplied all of this expression by 2. So we factor out that 2 first, and we will see that this is actually a difference of two squares. So it's 2 into 1 minus 4y squared. Let's look at the proof of the quadratic formula. In the next lesson, we equally be looking so much at using the quadratic formula to solve and the discriminates, and continue with forming a new equation using the roots of a previous equation. Alright, so we have here. So to do this proof, the first thing to do is to carry this c, this constant term, to the right hand side. Or we say we subtract c from both sides. to carry to the right hand side. We are left with this. The next thing is to make sure that the coefficient of x squared is 1. So we divide all through this equation by a, and this is going to give us x squared plus b over ax equals c over a. I'm leaving these spaces because I want to add something here. You will see as it's going to be done. At this level, we take a half of this term here. We also consider the sign here is positive, so we take a half of positive b over a. Whatever is here, we take a half of it. And a half of b over a is the same as b over a times a half, which is b over 2a. What do we do with this half? We square this half and add it to both sides. Note there's an equation. Anything you do to the left hand side, you must do to the right hand side. So we square it and add it to both sides. So we square it and then we add it to both sides. So b over 2a, all of that squared, plus b over 2a, all of that squared. So after squaring this, we add them to both sides. So when we simplify the right hand side, the LCM is 4a squared. 4a squared divided by a is 4a times minus c is minus 4ac. And when we divide the right hand side, we will have b squared. Now, the next thing, the left hand side can also be simplified as follows. We look at the terms at the extremes of the left hand side. We have x and we have b over 2a. We do not consider the squares. So we'll have x, the sign here is positive, so plus b over 2a, and we put the squares, the square. When you expand this particular expression, you will have back this one that is here, because this one is already a difference, is already in the form of a perfect square rather. This is already in the form of a perfect square, which is x plus b over 2a, and the right hand side, we already have it to be that. This is simple stuff. Since we are solving for x, we take the square root of both sides, and for the left hand side, we'll be left with x plus b over 2a is equal to b squared minus 4ac all over 4a squared. But looking at the lesson on surds that we saw previously, we know that this is the square root of the numerator over the square root of the denominator. And the square root of the numerator will be plus or minus. Note that each square number has a positive and negative square root. So plus or minus b squared minus 4ac. All that on square root of 4a squared is 2a's. So from here now, what is disabling us from having x is this b over 2a. We now carry it to the right hand side, and you'll be left with minus b over 2a plus or minus b squared minus 4ac on 2a's. They have a common denominator, so we can just bring the numerators together, and this is what we have as required. That's the square root. Where this term delta equals b squared minus 4ac is called the discriminant. So we have proven it's called the discriminant. Now, still with this formula and the discriminant stuff, this discriminant, if the discriminant is equal to 0, we can talk about the nature of roots. We can know how the quadratic looks like from the value of the discriminant. It tells us whether we have roots that are identical or distinct or complex. Whether the roots are real or imaginary, it tells us, gives us all of that information. So if the discriminant is equal to 0, then we have real and repeated roots. Repeated or identical, or the roots are the same. If delta is greater than or equal to 0, or let me say if it's strictly greater than 0, then we have real and distinct roots. Here, if it's strictly greater than 0, we have real and distinct roots. And if delta is strictly less than 0, then we have imaginary or complex or no real roots. Imaginary or complex or no real roots. That's what we'll be having. So thank you guys so much, and for the tutorials on this lesson, please go to our blog www.gcemathspanel.blogspot.com or go to www.gcemathspanel.com. You can subscribe to this channel, don't forget to, and you can follow us on Facebook, Twitter, and get to us on WhatsApp. You can get past questions, our monthly super quiz, and join our live lessons to prepare you for all exams. We always start in August. In fact, the lessons are ongoing. Send a message to us on WhatsApp or email. WhatsApp is faster, so that you can get to us. Don't forget to join our Facebook page and our live classes every Sundays. Thank you so much. I have been Dr. Miles, your host. Bye bye.